As you've seen, one way to control when code is run is with the functions setTimeout and setInterval, which run a function once a fixed amount of time has passed. Another way is to run code only when a user performs certain actions, such as clicking, typing, or even just moving the mouse. This will let users interact with your web page so that your page responds according to what they do. In a browser, every time you perform an action such as clicking, typing, or moving your mouse, something called an event is triggered. An event is the browser's way of saying, "This thing happened." You can listen to these events by adding an event handler to the element where the event happened. Adding an event handler is your way of telling JavaScript, if this event happens on this element, call this function. For example, if you want a function to be called when the user clicks a heading element, you could add a click event handler to the heading element. Well, look at how to do that next. Handler for a click event. Open the interactive.html document you created earlier, use file save as to save it as clicks.html, and replace its second script element with this code. Var click handler equals function event console dot log click event dot pageX event dot pagey h1.click handler. And we create the function click handler with the single argument event. When this function is called, the event argument will be an object holding information about the click event, such as the location of the click. Inside the handler function, we use console.log to output the properties pageX and pagey from the event object. These properties tell us the event's X and Y coordinates. In other words, they say where on the page the click occurred. Finally, we activate the click handler. The code h1 selects the h1 element, and calling h1.click handler means when there is a click on the h1 element, call the click handler function and pass it the event object. In this case, the click handler retrieves information from the event object to output the X and Y coordinates of the click location. Reload your modified page in your browser and click the heading element. Each time you click the heading, a new line should be output to the console, as shown in the following listing. Each line shows two numbers, the X and Y coordinates of the click location. Click 8843 click 6353 click 2453 click 12146 click 9355 click 10348. The page C figure 10 to 3. Figure 10 to 3. Coordinates in the browser, showing a click at the coordinate 3, 2. In this chapter, you learned how to write JavaScript that runs only when you want it to. The setTimeout and setInterval functions are great for timing code to run after a delay or at certain intervals. If you want to run code when the user does something in the browser, you can use events like click and mouse move. But there are many others. In the next chapter, we'll put what you've just learned to good use to make a game. Here are a few challenges to explore more ways to use interactive programming. 1. Follow the clicks. Modify the previous mouse move program so that instead of following your mouse, the heading will follow just your clicks. Whenever you click the page, the heading should move to the click location. 2. Create your own animation. Use setInterval to animate an h1 heading element around the page, in a square. It should move 200 pixels to the right, 200 pixels down, 200 pixels to the left, 200 pixels up, and then start again. Hint: you'll need to keep track of your current direction, right, down, left, or up, so that you know whether to increase or decrease the left or top offset of the heading. You will also need to change the direction when you reach a corner of the square. 3. Cancel an animation with a click building upon challenge 2. Add a click handler to the moving H1 element that cancels the animation. Hint: you can cancel intervals with the clear interval function. 4. Make a click the header game. Modify challenge 3 so that every time a player clicks the heading, instead of stopping, the heading speeds up, making it harder and harder to click. Keep track of the number of times the heading has been clicked and update the heading text so it shows this number. When the player has reached 10 clicks, stop the animation and change the text of the heading to "You win." Hint: to speed up, you will have to cancel the current interval and then start a new one with a shorter interval time. Let's put what we've learned so far to good use and make a game. The aim of this game is to find the hidden treasure. In this game, the web page will display a treasure map. Inside that map, the program will pick a single pixel location, which represents where the hidden treasure is buried. Every time the player clicks the map, the web page will tell them how close to the treasure they are. When they click the location of the treasure or very close to it, the game congratulates them on finding the treasure and says how many clicks it took to find it. Figure 11:1 shows what the game will look like after a player clicks the map. Figure 11:1. The buried treasure game. Before we start writing the code, let's break down the overall structure of this game. Here is a list of steps we need to take to set up the game so it can respond accordingly when a player clicks the treasure map. 1. Create a web page with an image, the treasure map, and a place to display messages to the player. 2. Pick a random spot on the map picture to hide the treasure. 3. Create a click handler. Each time the player clicks the map, the click handler will do the following. A. Add 1 to a click counter. B. Calculate how far the click location is from the treasure location. C. Display a message on the web page to tell the player whether they're hot or cold. D. Congratulate the player if they click on the treasure or very close to it, and say how many clicks it took to find the treasure. It'll show you how to implement each of these features in the game, and then we'll go through the full code. Now let's build the JavaScript for our game. First we need to pick a random location for the hidden treasure inside the treasure map image. Since the dimensions of the map are 400 by 400 pixels, the coordinates of the top left pixel will be x0, y0. And the bottom right pixel will be x399, y399. For the x value and a random number between 0 and 399 for the y value. To generate these random values, we'll write a function that takes a size argument as input and picks a random number from 0 up to but not including size. Vargetrandummer equals function size. Return math.floor. Math.random size. This code is similar to the code we've used to pick random words in earlier chapters. We generate a random number between 0 and 1 using math.random. Multiply that by the size argument, and then use math.floor to round that number down to a whole number. Then we output the result as the return value of the function. Calling Vargetrandummer 400. We'll return a random number from 0 to 399, which is just what we need. Vargetrandummer var width equals 400. Var height equals 400. Var target equals x Vargetrandummer width, y Vargetrandummer int. The section of code that sets the width and height variables, which represent the width and height of the img element that we're using as a treasure map. And we create an object called target. which has two properties, x and y, that represent the coordinates of the buried treasure. The x and y properties are both set by getrandemummer. Each time we run this code, we get a new random location on the map, and the chosen coordinates will be saved in the x and y properties of the target variable. The click handler is the function that will be called when the player clicks the treasure map. Start building this function with this code. Map.click function. Event. / click handler code goes here. First we use map to select the treasure map area because the img element has an ID of map. And then we go into the click handler function. Each time the player clicks the map, the function body between the curly brackets will be executed. Information about the click is passed into that function body as an object through the event argument. This click handler function needs to do quite a bit of work. It has to increment the click counter, calculate how far each click is from the treasure, and display messages. Before we fill in the code for the click handler function, we'll define some variables and create some other functions that will help execute all these steps. A variable called clicks at the beginning of the program outside the click handler and initialize it to 0. Var clicks equals 0. Inside the click handler, we'll include clicks, so that we increment clicks by 1 each time the player clicks the map. The distance between where the player clicked and the location of the hidden treasure. To do this, we'll write a function called getDistance. Like so. Var getDistance equals function event target var diff(x) equals event.offsetX target x var diff(y) equals event.offsetY target y. Return math.sqrt diff(x) diff(x) diff(y) diff(y). The getDistance function takes two objects as arguments, event and target. The event object is the object passed to the click handler, and it comes with lots of built-in information about the player's click. In particular, it contains two properties called offsetX and offsetY, which tell us the x and y coordinates of the click, and that's exactly the information we need. Inside the function, the variable diff(x) stores the horizontal distance between the click location and the target, which we calculate by subtracting target.x, the x coordinate of the treasure, from event.offsetX, the x coordinate of the click. We calculate the vertical distance between the points in the same way, and store the result as diff(y). Figure 11-2 shows how we would calculate diff(x) and diff(y) for 2 points. Figure 11-2. Calculating the horizontal and vertical distances between event and target. GetDistance. Points. The Pythagorean theorem says that for a right triangle, where A and B represent the lengths of the two sides bordering the right angle and C represents the length of the diagonal side, the hypotenuse, A2, B2 equals C2. Given the lengths of A and B, we can calculate the length of the hypotenuse by calculating the square root of A2 B2. To calculate the distance between the event and the target, we treat the 2 points as if they are part of a right triangle, as shown in figure 11-3. And the getDistance function, diff(x) is the length of the horizontal edge of the triangle, and diff(y) is the length of the vertical edge. To calculate the distance between the click and the treasure, we need to calculate the length of the hypotenuse, based on the lengths diff(x) and diff(y). A sample calculation is shown in figure 11-3. Figure 11-3. Calculating the hypotenuse to find out the distance between event and target. To get the length of the hypotenuse, we first have to square diff x and diff y. W. Then add these squared values together, and get the square root using the JavaScript function math.sqrt. Our complete formula for calculating the distance between the click and the target looks like this. Math.sqrt. Diff x. Diff x. Diff y. Diff y. The getDistance function calculates this and returns the result. The player how close they are to the treasure, without telling them exactly how far away the treasure is. For this, we use the getDistanceInt function shown here. Var getDistanceInt equals function distance. If distance, return boiling hot. Else if distance, return really hot. Else if distance, return hot. Else if distance, return warm. Else if distance, return cold. Else if distance, return really cold. Else return freezing. This function returns different strings depending on the calculated distance from the treasure. If the distance is less than 10, the function returns the string boiling hot. If the distance is between 10 and 20, the function returns really hot. The strings get colder as the distance increases, up to the point where we return freezing. If the distance is greater than 320 pixels, we display the message to the player by adding it as text in the P element of the web page. The following code will go inside our click handler to calculate the distance, pick the appropriate string, and display that string to the player. Var distance equals getDistance. Event, target. Var distance hint equals getDistanceInt distance. Distance. Text distance hint. As you can see, we first call getDistance and then save the result as the variable distance. Next we pass that distance to the getDistanceInt function to pick the appropriate string and save it as. Instead of making the player click the exact location of the treasure, well, let them win if they click within 8 pixels. This code checks the distance to the treasure and displays a message telling the player that they've won. If distance, alert, found the treasure in clicks. If the distance is less than 8 pixels, this code uses alert to tell the player they found the treasure and how many clicks it took them to do so. Now that we have all the pieces, let's combine them to make one script. / get a random number from 0 to size var random number equals function size. Return math.floor. Math.random size. / calculate distance between click event and target var distance equals function event target var diff x equals event.offset x target x var diff y equals event.offset y target y. Return math.sqrt diff x diff x diff y diff y / get a string representing the distance var getDistanceInt equals function distance. If distance, return boiling hot. Else if distance, Return really hot. Else if. Distance. Return hot. Else if. Distance. Return warm. Else if. Distance. Return cold. Else if. Distance. Return really cold. Else. Return freezing. / set up our variables. Var width equals 400. Var height equals 400. Var clicks equals 0. / create a random target location. Var target equals x getrandem width, y getrandem range. Programming.